So good morning, everyone. As I said earlier, my name is Josh Johnson. I'm a senior traffic engineer with HDR. I'm here today to talk to you a little bit about my experiences using StreetLight data on the I-405 167 mega program here in the Bellevue, Washington area. We've been using StreetLight for the last 2 years or so now, and we've been using it for all those applications that I just shared. So I'd like to just spend a couple moments today to highlight some of the key projects we've been doing, kind of hitting some of these different elements, and hope you enjoy. So a little bit about us, the 405-167 program. So for those of you not familiar with the Seattle region as well, so Seattle is here, kind of where this Redmond is, that's where we're at today. 405-167 corridor, it's kind of right here, comes down the east side, right here. Probably a lot of you used it to get here today. Our program is basically responsible for kind of what's shown in here, and there's different levels of responsibility that I won't get into because it'll take hours. But basically, we're responsible for the project delivery of different elements all along these two corridors through here. And this has been ongoing for about 20 years or so now. And that was all kind of spurred from the I-405 master plan. This master plan kind of gives us the framework, the vision of how we're going to be developing this corridor in the past, to the present, and the future today. A couple of highlights about our master plan here. As I said, it was developed in 2002, so we've been working on this for, well over 20 years. Key takeaways of this is it's a multimodal, multi-agency plan. It means we're not just focusing on infrastructure improvements. We're looking at this from different contexts, working with all our different stakeholders along the corridor. A couple of key components of this is we are widening, adding capacity to the freeway, and also looking at local streets. Doing quite a bit with transit as well, accommodating BRT, which will be coming here in the next few years. HOV, direct access ramps, park and rides, all that infrastructure to facilitate that type of mobility. Environmental enhancements, kind of trying to improve the natural environment in the area. But really kind of what I'm going to be focusing on today, and it's kind of the flavor of the day for our program, is our managed lane system and maintaining it and expanding it into the future. So a little bit more about our managed lane system as well. We've got quite a bit. It's kind of a good mix all over the place. A couple things I want to highlight. So over here, this is our SR-167 hot lanes. This is actually one of the first hot lanes opened up in the nation. Opened in 2008. It's been kind of going on in operations ever since. We've done a couple expansions on that as well. 2015, up here on the north in the corridor, we opened our first, what we call our ETL system, our express toll lanes. And this is a destination, a dynamic-based pricing system where a user will select the destination that they want to go. They'll see a price on that sign, and that's going to be the price that they pay. And the prices change every 3 minutes or so. And we're looking to expand these systems as well. If you look here in the orange, this is written to Bellevue. This is kind of our missing link between our two toll lane systems. We actually just awarded a contract on this project. We're expecting construction to begin either very, very, very late 2019 or early 2020. A year of opening kind of around 2024. And a couple of the projects I'm going to be highlighting today are going to be focusing on this project. Also, back to kind of this hot lanes project, we are expanding the system and looking to upgrade it. And I've got another project that kind of highlights that. So before I kind of share our project experiences, I want to spend a couple minutes why we ultimately selected StreetLight data. Either there's a lot of different choices out there to do kind of your origin destination studies or other various big data needs in here. And I've highlighted three, even though there's multiple reasons here. And probably the most important for us, it ultimately came down to cost. In the past, whenever we've needed to do origin destination studies, it's always been either using Bluetooth or other AirSage or other kind of technologies that are out there, and they've been clunky and frankly quite expensive. In 2012, when we last did it, I think our program spent $150,000 on doing an origin destination study. with StreetLight, we're actually able to have a lot more data available, finer level resolution than we did for a third of the cost. Ease of access. Minxing, who helps me out quite a bit here as well, she could probably speak to this as well, but ease of access is really important for us. With our program, our logo is flexible and nimble because our program director or other folks will be like, hey, I need some information about the users on 405 or whatnot, and I need that in 4 hours. Thanks. But StreetLight gives us the ability to go in there, query it, put something in, and 30 minutes later, we have some sort of data, and we can present that really fast. So that's actually been really nice for our program to be flexible and responsive in that regard. Finally, I think the thing that we really like is the data availability, that we have it everywhere. You can basically select any road, you can select parking lots, you can select areas, you name it. The data is there. There's not too much of a lag time in terms of that time period, only a couple months in the past or whatever, and you have really good resolution on that. So those elements plus some of these other things in there have been really important for us and helped us with our project delivery. So now I kind of want to highlight 3 project examples that our program's been working on. First one's kind of, this is our latest and greatest one we've been working on. It's more of a planning application, but this is deals with our toll system planning and implementation. So if you remember previously on the other slide, we're looking at 167 here. I said we've got a hot lane here today, and it's built in 2008. It's reaching the end of its useful life. I guess ITS equipment only lasts 10 years, something along those lines. Anyways, we're looking to upgrade that system. Today you pay a toll to get in, and once you pay that toll, you're done. We're looking to upgrade this to like our Renton to Bellevue and North End section, where we're going to have that dynamic and destination-based pricing system. Meanwhile, we're also working with our partners from the Olympic region, from WashDOT, in terms of expanding our toll lane system here. So we're looking at widening the freeway through here, putting in either our hot lane or HV lane, tying that into our existing system here as well. So we kind of have both of these projects going on at the same time in here. So, hey, we've got StreetLight. Let's see how we can use it and how it can help inform some of the decisions here. So we used a lot of our StreetLight data to do travel pattern identification, help us identify where those travel zones or sheds should be, and kind of start to get kind of a sketch level of what kind of users and type trips we would have in this toll lane system. So we used a lot of StreetLight data to basically build GUIs like this. This was the tool that we developed for the program. This is just an Excel-based application where we took StreetLight OD information. We looked at basically freeway on and off ramps, main lines in here, synthesized that with actual count data, and looked at kind of the different dynamics along the entire corridor. And we made this all really go and select half an hour time period here or there, or multiple half-hour time periods, and any number of origins and destinations along the way. What we found was most useful about this is kind of this chart up here. Let's see if I can highlight it. Yep, there we go. We call that our rainbow waterfall chart. And what it is it basically takes all the different OD components that we have based on all the different colors in here, and then some of them kind of gives you your total volumes anywhere along the way. And to help out with the toll zone planning process, basically what we're trying to do is we're trying to find these dips and spikes in here. These are our waterfalls in here. And basically anywhere you kind of have those big dips or spikes kind of indicate those travel sheds that you're looking for. So we were able to kind of take a look at this data and say, yep, right here, SR18, that looks like a good travel shed for us to use for this. Hey, there's something kind of going on here too at SR516. It's kind of about halfway through. That looks good. So we were able to kind of look at some of this data, break it down real quick, and actually come up with some pretty good decisions about kind of where we wanted those fare zones. We also were able to use these tools to kind of dig a little bit deeper. One of the challenges we have with developing toll lane systems and whatnot is making sure that we have equity across the corridor, and we're not just necessarily filling these lanes full of people right from the beginning. So we took a look at, hey, what's our user base right at the beginning of the toll lane system, kind of down here. Where are they going? And how are they going to impact our facility planning and whatnot? So we were able to kind of take a look at this, and see, okay, out of this, maybe about 20% of these trips are going to go all the way to the north end. Depending on how we set the toll rates and whatnot there, we'll drive that demand a little bit, and just trying to make sure, we have enough space available, and see if there's, different OD patterns or other things that maybe, we don't want these short trips in here, or we want to restrict this or whatnot. So having a tool like this and having StreetLight data as kind of that back end, the crux of kind of what led to this development with this was invaluable for this planning process. So that process is ongoing. It's been really successful so far, and we should see some findings here pretty soon. So now I kind of want to pivot and talk a little bit about how we're using StreetLight for design-related purposes. And this was more testing the functionality of our designs. This was kind of, we're calling this Unraveling the 112th Avenue Southeast Mystery. This was kind of I want to call it a pet project of mine, because there was something that was really bothering me on the corridor. So provide a little bit of context. This is in Renton to Bellevue. So this is just kind of south of here, just south of I-90. This is Lake Washington right here. We got a little dinky service interchange here. This is 112th Avenue Southeast. There's a whole bunch of multi-million-dollar homes here. You got to be very rich to get here. Not a lot of connections in here. So you can see there's a lot of single family, other things along those lines in here. We have a couple more major interchanges up here. Coal Creek Parkway is kind of up here. 44th Avenue, where Seahawks training facility is down here. Those are kind of more where you would think you'd have a lot of traffic demand. So there's not a lot of local destinations. But when we look at the traffic volumes in this area, we see a very interesting pattern here. AM peak, oh my gosh, there's 1,200 trips. And this is, as I said, this is a little system interchange. I mean, we have stop signs here. There's no signals or anything. That's an insane amount of demand. PM peak, it's definitely a lot less. It's about a quarter of it. So we knew something was going on here, but we couldn't ever find these trips in the PM peak, and we didn't really have a good handle on it. So we're like, hey, how can we use StreetLight data to help answer this question and unravel this mystery of where these trips are and where they're going? Well, so we knew the obvious answer to this. They're avoiding 405. So this is the heat map, and basically anywhere you have yellow, red, and black, that means there's a lot of congestion, a lot of traffic. You kind of see the time in here. This is your direction of travel. So you see, not a lot of people want to be on 405 in here, and here's that 112th interchange. Hey, I've missed all congestion, so I'm going to go and use back roads. So we took a look at that. So we kind of did a two-part exercise with StreetLight data. We did kind of your typical, origin destination with a middle filter study on here on the left, where basically I put the middle filter on 112th Avenue through here and looked at all the origins and just plotted this in simple GIS map in here. And we were expecting, most of the trips kind of in this general area, kind of between those two interchanges. And what was pretty shocking is, even though we have these percentages in here, we saw that 60% of the people that were using this interchange were coming from further south down here. Like, well, okay, those are long trips. What was even more shocking going through this analysis is we had 15% of the total trips coming from those routes, 169, 167, and I-5. So those of you who are local, you know that those are freeways. And trips are on freeways, getting off the freeway to go on local streets just to get back on another freeway. So we're like, whoa, okay, that's very interesting. So we're like, okay, very cool. How are the trips getting there then? So this one, we were pretty creative on developing this, but we took a look at the different route choices in here. This was a whole series of ODs with middle filters. We had middle filters all over the place on here to kind of identify where these trips were going. And we knew, Lake Washington Boulevard, Coal Creek Parkway here were pretty predominant routes. But I think the thing that just really shocked the program was looking here. you see that we already have 10% of trips here. This is a 405 interchange right here. These trips, and you can pick up more and more people. Here's another 405 interchange right here. And they're basically taking these side streets, completely avoiding 405, going through our 405 interchanges before they got on to the facility up there. So why was this important for us? Why did this matter for design-related purposes? Well, right in Bellevue, we are redesigning several of these interchanges. We are redesigning 44th. We were redesigning a good chunk of 112th. And we had to make sure that our forecasts and other things were in alignment with the design that we did. So we actually did a lot of sensitivity testing in terms of what if these trips divert? What if they change the patterns? Is the design flexible enough to accommodate some of these different travel patterns and other things that we just didn't quite pick up in the travel demand modeling exercises and whatnot? So we used a lot of that to kind of help inform designs, change some turn pockets, look at different elements like that. So it was very informative. And I should note, this whole analysis here, this was about a day or two worth of work. So we were actually able to do this fairly fast. So that was kind of our design application. Last one I want to kind of briefly talk about today is our construction application. And this one deals with allowable closure. As part of a program, anytime we have new projects and other things along those lines, we're responsible for developing closure hours to help guide contractors when they can go and close certain lanes on various freeway facilities and stuff. And the way that WSDOT does this analysis is basically their number one goal is to minimize disruptions to the public. So they don't allow lane closures during the middle of weekdays. They don't allow lane closures at night or during weekends, and they try to minimize when they allow the closures to basically at night. And the way we do this analysis is, you take a look at traffic volumes 24 hours a day, identify a capacity during construction, maybe 1,500 vehicles per hour per lane. You start looking at night, you find that point on your chart where it's like, yep, 9 o'clock, okay, traffic volumes are less than that, and 5 a.m., okay, that's when traffic volumes get to that point, and that's when you assign your closure hours. This is great for the traveling public because they experience minimal delays through construction zones. From a project delivery side of things, especially working with contractors and trying to get projects built and delivered as quickly as you can, it can really kind of extend your project durations. It can add a lot of extra costs, other things along those lines. And it was one of the number one things that we kept hearing from contractors was like, how can we get more closure hours and other things so we can actually build these projects? So this is how we use StreetLight, was like, okay, right in Bellevue, we know that we have some good detour routes that we want to do. So through here, oops, wrong button. This is kind of the airport down here. This road is I-5 and then I-90. We knew that, we could direct traffic from basically this major system interchange to this major system interchange up here through a series of EMS signs and positive messaging and other things along those lines. So we did basically a simple OD study in here and identified what percentage of trips starting here went all the way through. So, like in this case, we saw about 40% of all traffic starting at this point went to here. And conversely, it was about 20% in the reverse direction. So our team, in collaboration with different DOT organizations, said like, okay, that's the total traffic. How much of that do we think we can capture and divert over to 405 or to I-5? Is it a third? Is it half? And kind of looked at some of that and said, okay, well, what if we move a third over? And we did that, and then we took a look and redid our closure hour analysis. And what we found was, hey, that bought us 30 minutes, 45 minutes on some of these closures, which doesn't sound like a lot, but when you scale that over, 15 miles of freeway over 3 to 4 years, you're talking serious time savings for these contractors and stuff. And, so we used a lot of that to help inform kind of that analysis. And for a little $5,000 cost that we had to purchase the StreetLight data here, we heard from our contractor, and I'm going to knock on wood that this actually happens, is they reduced the construction period from 4 years to 3 years on this project. So, and MOT is always kind of a big part of how that's going to play. So I hope that StreetLight had a hand in that there. So in conclusion, and this is the token StreetLight slide that they made me put in here, the refinements and what would we like to see from the program. So I'm going to start with the refinement piece here, and I think probably all of us have kind of seen this a little bit as you're kind of digging into the data. You always kind of have those weird trips. You're going to like scratch your head a little bit, like where are those? Well, why do we have those? And it depends on what data set you're having, but in a lot of times we were saying about 5% of the data set just had some unusual things going on, and we were having a hard time trying to put our hand on them. We knew that they were occurring, but what were they? Are they transit trips? You got a bunch of transit routes on fixed lines. You have your TNCs, just doing back and forth constantly and kind of giving you some illogical things or some trip chaining, activity-based stuff going on. For us, it's good to understand that those trips are occurring, but if there was a way that we could I don't know, somehow classify them or something like, hey, we think these are TNCs or these are this or that, that'd be fantastic. We'd also like to see kind of continued refinement of the travel time data that we have, especially getting a little bit better resolution, confidence, and some of that data that we're seeing, especially on the LBS side. This seems to be one of the more upcoming asks that I'm hearing from my clients and other things. I was like, hey, we've got all this great OD data. Let's get some travel time information tied to it. We have some travel times in some places that we can use, but we want to make sure we have real strong and solid travel time data as well. A couple other things, more the what would we like to see. Most of my presentation here was on managed lanes. We would love to see what's in our managed lanes versus what's on the local street. And part of the challenge is we have buffer separated, not a lot of differentiation between those. We understand, with GPS and LBS data that your resolution isn't quite as refined, and we're hoping that, as technology and other things progress, that maybe we can kind of get that resolution so that we actually know, where trips are starting from outside of the toll lanes, where they're entering the toll lanes, and then where they're ultimately leaving. So we got to have a kind of better handle on how many of those people are taking the long trip through the toll lanes versus kind of the short ones. Finally, some visualization tools and applications. We think that some of the visualization tools that are available are really helpful. I also think that there's additional room to expand and grow upon those. Something that I would love to see is the ability to kind of share some of this data that you're seeing immediately with your clients. There's some of the other big data tools out there, your Tableaus, your Power BI, you can kind of share some of that stuff online and, give that to your clients. Having some of that kind of instant gratification, as it were, so to say, I can send a link to somebody, hey, here's the data analysis that we just did. Come take a look at this. I think that would be a really cool application and something else we can do. So anyways, that's my presentation. So questions?